During this video, you will discover how to use cloud storage to define a key structure for high-write applications. Using cloud storage to define a key structure. In this video, we're going to talk a little bit about cloud storage, and we will discuss how to organize cloud storage and some things to consider when you're integrating cloud storage with a high-write application. So an application that's going to perform a lot of writes to your cloud storage. So up under the search bar, let's type in cloud storage, and let's go to the cloud storage product page. From here, you'll see any of your existing buckets. Let's go ahead and create a bucket, and let's give our bucket a name. So I'm going to combine Richard-Demo and just some random numbers at the end. Go ahead and click Continue. I want a multi-region bucket. Right. So this is one thing you have to think about. If you want to have high availability across a large area, you want it a multi-region bucket because your users may be in all different areas of the globe. So you want to decrease that latency by using a multi-region bucket, and that way, you've got a place for your users all over the world to upload files that's close to them, and therefore, you'll reduce the latency. So I'm going to choose multi-region, all regions in the United States. I could choose all regions in Europe or all regions in Asia if I wish. I'm going to go with all regions in the United States. So it really comes down to what area or what regions do you expect most of your users. Click Continue. Choose a default storage class. Obviously, I need standard, frequently accessed data, short-term storage. The other options for storage class are nearline, cold line, and archive. The other option for access control is fine-grained. I'm just going to leave the access control to uniform right now. Click Continue, and I'm going to turn on object versioning. So I'm going to take a maximum number of versions per object to be 1 and expire non-current versions after 7 days. I could also create a retention policy as well, and this is important for high-write applications because a lot of times things may get written over by mistake. You want to have some form of versioning so you can go back and get previous versions if you need to. So go ahead and click Create. It creates our bucket. And from here we can upload files, we can upload folders, we can create a folder, right? And create some structure to our bucket. And it's important to note that cloud storage operates with a flat namespace, which means that these folders don't actually exist within cloud storage. So if we create an object and we create a folder, so let's go ahead and click Create Folder. And let's say we call it Folder 1. And then we go into Folder 1 and we can upload a file of an image. This image now is located under Folder 1, so these folders aren't exactly folders themselves. Again, it's a flat namespace, but what we're really doing here is that we're adding a string called Folder 1 to the object's name. You do get a visual representation of folders, and this is something that we're used to seeing in like Windows and so on. But if we go back to our again, these folders are just prefixes only. It's just a string we're adding to the name. And that's what makes buckets good for our applications. We're going to get a lot of writes. We don't have to transverse multiple hierarchies of folders because it's a flat namespace. So this is an example of object storage. And object storage organizes unstructured data. It's all about individual objects. Therefore, it's pretty much unlimited from a scalability point of view. Files are stored as objects in different locations. Each object has a unique identifier, and each identifier has a lot of metadata. And that metadata can be variable, and it can be significantly greater than file metadata. And it ranges in size from kilobytes up to gigabytes. A big advantage of this type of object storage is low cost. Massive scalability is also a big advantage. The scalability is the direct result of the object storage shared nothing architecture and flat structure. Right. And in a high-write application, where maybe this is a back-end storage location for an application where users upload images, then you need to be able to massively scale as your application gains in popularity. One last thing to look at regarding these cloud buckets in a large-scale high-write application is the use of parallel composite uploads. So for uploading large files, you can take advantage of parallel composite uploads. And in that type of an upload, a file is divided into 32 chunks, and the chunks are uploaded in parallel to temporary objects. Then, that final object is recreated using those temporary objects, and they can make your upload significantly faster. And we know that faster is much better, especially in an application that's doing a lot of writing. So I hope this video showed you a little bit about cloud storage buckets, a little bit about their hierarchy, a little bit about parallel composite uploads, and how to kind of set up your versioning in your bucket to really thrive in a high-write application. Using Cloud Bigtable to define a key structure. Use Cloud Bigtable to define a key structure for high-write applications. Using Cloud Bigtable to define a key structure. Your host for this session is Richard Spencer. In this video, I'm going to show you how to design a Cloud Bigtable schema for high read and write applications. So Bigtable is inherently designed for low latency data access, where you really need the ability to scale, and you need reliability. And it's the same technology behind Gmail, Google Maps, right? All these humongous Google applications, which serves billions of users. So let's get started. Let's come up under the search bar. Let's type in Bigtable, and you'll see a product page for Bigtable, and we'll be brought into the Bigtable console. First thing we need to do is to create an instance. So let's go ahead and click Create Instance. You'll notice the price, $468 a month. Very expensive. So if you follow along, make sure you delete your instance as soon as the demo is finished. So I'm going to put in my instance name. It's going to be Richard-demo-instance. And the instance ID is going to be Richard-demo-instance-1. Go ahead and click Continue. I'm going to choose an SSD here. Obviously, it gives you much lower latency. And I'll configure my cluster. So it's just going to be Richard.demo-instance-1-C1 for cluster 1. I'm going to put it in US East 1 in any zone. I don't want any scale. I don't want to make this machine to be 2 nodes, because if I say 2 nodes, the price will double. So I want to ensure I'm at 1 node, and I stay at 1 node. I go ahead and click Create, and that'll create our instance for us. And from there, we can access this instance and create a table, and look at how to progress back up to literal layout right connect, because that's where cooking. So once your instance is created, you can click on your instance, and you can get the overview. It shows you everything that you've just set up. Shows you your CPU utilization. So you get some metrics here as well, and the cluster that it belongs to. The metrics included are CPU utilization, rows, throughput, and system error rate. We're interested in tables, so we're going to create a table for our products that may be used by typical retailer in inventory, right? So we're going to create a table, and we're going to call it inventory. So I'm going to go ahead, I'm going to click Create Table. For table ID, I'm going to call it inventory. And here you see add column families. So to help organize the data and limit what we're pulling back, columns are grouped into column families. And these column families group the fields that are typically accessed in reading purposes in the same request to ensure more efficient access. So in this example, in our inventory, we may have inventory description fields and pricing or inventory fields. A list of products may use data from the descriptors, but maybe don't need to pull back all the store-level inventory. So we can create a column family for these product descriptors. We can go ahead and click Add Column Family. It's asking for a column family name. So I'm going to add a column family name. So I'm going to add a taxa integration reference. And then you see your junk collection policy. So your junk collection policy is kind of a lifecycle based to start filtering out items in your actual table. So if you hover over the question mark, you can see that for advanced use cases, you might need a combination of max edge and max version. Right, so we're gonna never collect junk, and we're gonna go ahead and click Done. The other options under the junk collection policy are age-based policy, version-based policy, and customized policy. And I'm gonna go ahead and click Create. So that will create the table inventory, and it has a column family of descriptor. So now the table is on our instance. Let's go ahead and open up our command line, and we're going to use a CBT command line. So I'm going to come up. I'm going to activate my Cloud Shell. You can do this on a virtual machine as long as you have the Google CLI installed. So first thing I need to do is tell Cloud Shell what instance I'm using. So I'm going to type in echo instance equals. And it's going to be Richard-demo-instance-1. And I want to pipe this out to my actual CBTRC file. So now it knows what instance to use. I don't have to specify the instance in a flag over and over. So now if I do a CBTLS, it'll look and you can see I have an invio table. So that's great. We're working, we've got our table recognized. Now, we need to go ahead and start looking at some rows, columns, and cells. All right, but before we do that, I want to run one more small command. CBT-LS inventory. And you can see that it brings back our column family of desk row. And so everything's working as it should. Let's go ahead and clear our screen. Now, just like relational databases, we do have a concept of row, columns, and cells. Each row is identified by a unique key that we provide. Cells are the intersection of a row ID and a column ID. So in our case, the row ID is going to be a unique product ID, and we'll add a title for it in the descriptors column family. So let's go. Go ahead and type in CBT set inventory. Now we have to give it a row ID, so I'm going to pass in the item. I'm just calling item 123, and then our description is going to be the title, and that title is going to be fishing rod. So we're giving in item 123 a title of fishing rod, so we put it in, it's added. Now, if we do a read on our inventory table, CBT read inventory, you can see that we have IIM 123 with the description title of fishing rod. And you'll know we didn't explicitly create the columns. With Bigtable, we get dynamic schemas that allow us to create columns on the fly. And that's where it's really good for high read applications. Now let's clear our screen and let's rerun that last command. But this time, instead of fishing rod, we're going to do our enter. We go ahead and hit enter. Now we do our 36pt read on inventory again. You'll see now we've got 2, so it doesn't overwrite the first record. It gives you a second record with a timestamp, so you get 2 versions of the cell. So this also relates back to high-write applications because you may not want to store every version created. So if we look back on the garbage collection that we did, set up previously, that's where that comes in. We don't want to be constantly keeping all the new versions in heavy write, so we may want to set up a garbage collection policy based on the time and the cell. Maybe we only want to keep one version. So I clear my screen, I'll do CBT set GC policy on the table inventory, and it'll be deskgraphed. And I'm going to go with max versions equals 1. It appears to have done it. Now let's review the column families again, CBT LS inventory. Now you can see the GC policy has changed, right? So now we're finally only keeping one. Under GP policy, it reads, versions all on track, competitors greater than 1. So now as a data storage technique, it's not going to actually keep that second version. If you do a CBT, read again, CBT read inventory, you'll notice that it still has the 2 timestamp versions again. So like I said, it's a data storage technique. It's not for limiting query results and could take up to a week before data that's eligible for garbage collection is actually removed. So you won't pull back all versions of the cell anyway. Instead, we may do something like this. I'll clear my screen. CBT read inventory cells hyphen per column equals 1. And it gives us back the newest timestamp. So I hope this video showed you how to create that Bigtable instance, how to create your Bigtable table, how to create column families, and how to configure garbage collection for your high read and high write applications.